Hi guys, how's it going? When you are looking at application workloads running on Kubernetes, there are two types, stateful applications and stateless applications. By far, we mostly see applications are stateless, which means running applications without holding the client data. So when the pod is evicted or off, we can delete or replace it without any additional concerns. One key principle of microservices is to keep the applications as stateless as possible. However, there's always a case where we need an application to hold client data. For instance, an application saves the client data generated in one session for use in the next session with that data. That's how we define stateful applications. In Kubernetes, stateful applications use Kubernetes volume to store data. What we usually do is to mount a storage to the pod or allocate the storage to the pod dynamically. There are also two types of storage in Kubernetes, ephemeral storage and persistent storage. In this video, let's have a look at ephemeral storage. By the way, if you're looking into building a lab environment of this video, you should check out those two videos. One about spinning up a Minikube cluster and another one about deploying a Linux VM on M1 MacBooks for free. Let's get right into it. First thing first, we need to make sure we're off to a good start. So I'm gonna check the current status. My node is up and I also have enough resources to deploy a new pod. Therefore, I can create a new YAML file. In this YAML file, you can see I define my pod. So I have one container in this pod. From there, I need to mount a storage. So I define a volume as a storage. Here I call it my volume. With a mount path, set tmp start storage. And then in the volume section, define the name of the volume, then an empty directory. An empty directory volume provides a writable directory accessible to each container in the container group. So the containers in the group can read and write the same file in the volume. Of course, here we only have one container. In case we have multiple containers, it can be mounted using the same or different paths in each container. With that in mind, we can start to deploy this YAML file using kubectl apply command. And then we can see we have created a pod. You can check out the status of this pod if it's up and running. Then you can get more details using kubectl describe pod command. And here you can see we have details, storage mounted to this pod, as well as at the end you have events where you can see how to put an image and restart the container. That means our pod is up and running with the storage. I know we discussed earlier in this video that one container per pod is the ideal case of a microservice, but in the real world, you always find us to deal with multi-container use cases. You may ask, what is a multi-container pod? Multi-container pod means there are multiple containers in one pod. So the good news here is that multiple containers in the same pod can share the same mounted storage, although each container comes out the empty directory that we saw earlier in this video in a different repository. So now, let's look together to see how it represents in the YAML file. You can see our YAML file will define a pod. So we have two containers in this pod definition. And you can see in the containers section, we have busybox, another one is nginx. What's interesting here is when we check out the volumes, here is we define one storage is a shared data, then we use empty directory just like we did before, and this is storage shared by those two containers. So if you go back to the container section, we have mounted the storage for busybox. It's called a shared data, and the mounted path is /tmp and data. For another container, we have mounted the same storage, although it's under the path /pod data. Now you can close the file, then deploy use kubectl apply command to deploy this YAML file. And we can see here we can deploy it and check the status. Wait until the pod is up and running. Let's do a kubectl describe pod. That's where we can check out details to see if the storage is mounted successfully. In this part actually we can see for those two different containers they mounted into different paths, which proved what we just did before. Thanks for watching. Check out this Kubernetes in 30 days challenge playlist in the description down below. I'll see you guys in the next one.